Yo, yo, yo! This is Mr. O, and today we're gonna try to prove similar triangles. We're gonna try to apply the two-column proof in proving similar triangles. Okay, so let's go ahead now. Remember that similar triangles they need to have corresponding angles are congruent, and the corresponding sides must be proportional. Okay, that's something we should remember, and we can prove that the two triangles are similar using AA angle side similarity or side similarity. Okay. Again, the angles must be congruent and the side must be proportional. Okay. So let's go ahead now. Number one here, we're given that MN is parallel with JL. So give this picture is given. So MN is parallel. Again, if they are parallel, you should have a hint that you're probably going to use the alternate interior, alternate exterior, corresponding, same side, those definition. Okay. Okay. So in making a two-column proof, remember that we're gonna on the left side we write the statement here, and on the right side we put our reasons. So that MN is parallel with JL. That is given. That's the reason for writing that down. And if we look at the picture here, we say that these are parallel. But before anything else, what we're trying to prove? We're trying to prove that the JKL, triangle JKL, where's the triangle JKL? Let me clear this out here. Triangle JKL is, let's say, triangle JKL is the orange big one, is similar to MKN. MKN, okay? The pink one. The orange is similar to the pink one. We know that they share something. What are they sharing? The two triangles are sharing same angle, angle K, right? So we can say that angle JKL is congruent to angle MKN. What's the reason there? That is reflexive property, because it is equal to itself, right? Next, we know that these two lines are or segment are this side are parallel, and the transversal line here could be this green line here. And then we can say that this angle here, this black angle here, and that black angle there are going to be congruent, right? That will be angle KJL is congruent to KMN. Why are they congruent? What do you know about the two black angles? I know they're congruent. For what reason? Remember, this is coming from a parallel line and transversal. What do you know about them? They are corresponding. You're right. Corresponding angles. Okay? They're corresponding angles. So now you can see here, if I'm going to erase this portion so you can see better, we know that this angle K are congruent and this angle M here and J are congruent. We can say now that the two triangles are similar, right? JKL is similar to triangle MKN using angle similarity. Sorry, similarity. Okay, kaboom. Given EAB and DCB are right angles. So where are those? EAB, so this is right angle, and DCB. Those are right angles. When you say right angles, they measures 90 degrees, 90 degrees, okay? And we're trying to prove that EAB and DCB are congruent, okay? DCB. All right, there you go. Let's go ahead now. So first, the statement and our reasons. Our first statement is always the given angle EAB and angle DCB are right angles. That's given. The next one there is that since that's congruent, right? What do you know now if they're right angles? Their measurement, the measurement of EAB is equal to 90. The measurement of DCB is equal to 90 degrees. Why? It's definition of right angles. Definition of right angles. If they're right angles, then their measure is 90 degrees, right? Now, since that's 90, we know that the measurement of EAB is equal to the measurement of DCB, right? What's the reason for doing that one? They're both 90, so these two here are equal. So therefore, that is substitution. Okay. Next, this is a measurement. This measurement is equal sign. I like that to be in a congruent format. So I can write angle EAB is congruent to angle DCB. That's definition of congruent angles, meaning to say when you convert equal sign to congruent or congruent to equal sign, that's definition of congruent angles. Okay. And now we can say that these two angles are congruent. Okay, that's very simple. Let me have some space here. Okay, so we know now that these two here are equal. What else can we say that are equal? Can you see something here, guys? I see an X. Can you see that X there? Yes. Every time you have an X, you know that this angle here are congruent. For what reason? Vertical angles. You're right. Angle. Don't write angle B. You gotta be specific. I'm gonna start with angle ABE is congruent to what's the partner of A? The partner of A is C. Angle CBD are congruent for using VAT. What's VAT? Vertical angle theorem. Okay, now we have proved that this angle are congruent, these two here, 90 are congruent. Is that enough for us to say the triangle EAB is congruent with triangle, no, not congruent, I'm wrong, similar. EAB is similar to triangle DCB? Yes, using AA similarity. Similarity. I have here LM over PQ is equal to MN over QR is equal to LN over PR. Prove that angle N and R are congruent. So here you can see that we have the three sides, LM, and then matches with PQ, MN matches with QR, and NL and BR, that they are already proportional, right? Because they are said to be equal. So I can write here LM over PQ is equal to MN equals over QR equals LN over PR. That's given. Now, if they're given that these three sides are proportional, is this enough for us to say that the sides are proportional? Yes. So by what? We can say the triangle, where do we start? MLN is similar to triangle. What's the partner of M? The partner of M is Q. So I'm going to start with Q. What's next? What's the part of L? L matches with PR. Using SSS similarity. So since now we have proven that the two triangles are similar, we can say that the angles, the corresponding angles of similar triangles are congruent. So this is like a counterpart of CPCTC. Corresponding parts of congruent triangles are congruent. This time has to be similar instead of writing congruent triangles. So we're gonna say that angle N is congruent to angle R using the CPCT side of the similarity, which is congruent. No. Similar triangles. No. Which stands for corresponding parts of similar triangles, parts or angles of similar triangles are congruent. Take note, you have to emphasize corresponding angles because the sides are not congruent with similar. So corresponding angles of similar triangles are congruent. Okay, there you have it.